The vastness of space continues to fascinate scientists and laymen alike, and recent discoveries are pushing the boundaries of our understanding. The new revelation has caused a significant split among scientists as they study the findings. The long-awaited moment of clarity has arrived as renowned astrophysicist Neil deGrasse Tyson unlocks astonishing insights into the universe. Among those discoveries is the sighting of 500 unidentified objects through space by Voyager 1, an event that confused and excited the scientific community. Voyager 1, launched by NASA in 1977, traveled an astonishing 14.5 billion miles from Earth. Originally designed to last only 5 years, the spacecraft exceeded expectations thanks to careful planning and the foresight of the designers. It continues to deliver invaluable data, revealing more about our cosmic neighborhood than we ever thought possible. How a 1970s-era spacecraft can still function and transmit groundbreaking data today is answered by its robust design, which includes 2 redundant computer systems and efficient power management strategies. One of the main secrets of Voyager 1's longevity lies in 2 redundant computer systems. Each Voyager spacecraft, including Voyager 1, was equipped with 2 control computer subsystems, the Flight Data Subsystem, FDS, and the Altitude and Attitude Control Subsystem, ACS. This redundancy acted as a critical safeguard, allowing for seamless transitions between systems and the ability to activate inactive computer components, extending their life. Designing the spacecraft as a distributed system with 3 pairs of redundant computers ensured that even if one system failed, the other could take over and prevent critical failures. Power management is essential to maintain the reliability of Voyager 1. The distance of a spacecraft from the Sun, where it can use solar energy, is a significant challenge to maximize energy efficiency. Engineers had to come up with innovative ways to save and optimize energy consumption. The power management strategy used by this amazing artificial probe is truly remarkable. One critical part of power management is the selective shutdown of non-essential systems. Engineers carefully evaluate which components or subsystems are not critical to achieving primary mission objectives. For example, heaters associated with certain scientific instruments have been deactivated. These heaters were originally designed to keep instruments at certain temperatures for optimal performance. When they are turned off, power consumption is greatly reduced, extending the overall lifespan of the spacecraft. This decision to disable non-essential systems is not taken lightly. This requires careful evaluation of the trade-offs between energy conservation and mission science objectives. Engineers work closely with scientists to ensure that disabling certain systems does not compromise the quality and availability of scientific information. The goal is to find a balance that maximizes efficiency and maintains critical functionality. Voyager 1's power management systems also adapt to changing conditions in its environment. As a spacecraft moves farther from the Sun, the available solar energy decreases. To compensate for this, Voyager 1 will adjust its power consumption accordingly. This adaptive approach ensures efficient allocation of available energy resources to support core functions and data transmission. Over time, there have been constant technical advances and innovations in power management techniques that have allowed engineers to improve and optimize the power systems of the Voyager probes. These improvements include more efficient energy distribution, advanced battery charging technologies, and advances in energy legislation and regulation. Thanks to these careful power management strategies, engineers successfully extended the life of Voyager 1, allowing it to continue its remarkable scientific journey through space. Despite all this careful planning and design, the depths of deep space remain unpredictable. One such unexpected twist in Voyager 1's journey was the spacecraft's claim to have spotted 500 mysterious objects. This revelation caused quite a stir and caused great concern among the scientists working on the project. These mysterious signals and data anomalies came as a complete surprise. Voyager 1 began sending telemetry data back to Earth, but the readings were strange, and there was no clear explanation of what was happening. Scientists have classified this phenomenon as an anomaly. Despite the erroneous transmission, Voyager 1 continued to respond to mission control commands, albeit with a slight delay in communication. This created a difficult situation and deepened the mystery. What was particularly difficult about that anomaly was that it did not trigger Voyager 1's internal security systems. These systems are designed to activate when anomalies are detected, putting the spacecraft into safe mode, allowing engineers to investigate and diagnose the problem. In this case, however, Voyager 1 continued to operate without entering safe mode, adding to the plot. After extensive investigation, an anomaly was detected in the Altitude and Articulation Control Subsystem, ACS. ACS plays a crucial role in precisely guiding the spacecraft and controlling its movement. It was determined that the ACS was sending telemetry data through an onboard computer that had stopped working years ago. This decommissioned computer, which should not have been involved in data processing, somehow got stuck in the process of transmitting telemetry, which resulted in the data being sent back to Earth. Now the task was to correct this anomaly and find out if there really are 500 unknown objects. The solution included instructions for the ACS to direct the telemetry data to the appropriate work computer. This repair was considered low risk and was successful. Fixing this anomaly was not without its unique challenges, however. One of the mission team's most significant obstacles was a significant delay in communication. Voyager 1 is now approximately 14.6 billion miles from Earth, a truly amazing distance. As a result, radio signals take a significant amount of time to travel through this huge area. When NASA's Deep Space Network, DSN, mission team sends a command to Voyager 1, it travels at the speed of light as a radio signal. DSN is a vast network of giant radio antennas strategically placed around the world. Its main function is to provide two-way communication between Earth and deep space missions. DSN collaborates with various space agencies around the world and creates a unified effort to explore the mysteries of space. Communication with Voyager 1 is via radio waves using the massive antennas on its DSN stations. Either 23 GHz or 8.4 GHz frequency is used to transmit data from the spacecraft to Earth. In contrast, when sending signals from Earth to Voyager 1, a frequency of 21 GHz is used. Despite the enormous speed of light, it takes about 22 hours for the command to reach the spacecraft even at this speed. This delay makes communication with Voyager 1 difficult. The task force must carefully plan and execute commands, taking into account the expected response time. Any errors or problems may cause further delays and complications. During the investigation of the anomaly, this time delay was a particular challenge. This meant that diagnostic and troubleshooting procedures were greatly expanded. The instructions had to be carefully crafted with a 22-hour wait before receiving confirmation or response from Voyager 1. But here's the important part. Despite the considerable delay, every message sent to Voyager 1 was not just an addition of data, it was an essential part of the mission.
Time lag may limit real-time control and communication, but it does not diminish the importance of communication. Each post was an important piece of the puzzle to solve the anomaly. Later, the anomaly was fixed at its source and the faulty computer was turned off. Voyager 1, a majestic spacecraft, could then continue its extraordinary journey through the vastness of space, sending valuable information and knowledge back to Earth. Now that we know that the previous malfunction of the spacecraft has been fixed, let's look at the remarkable achievements of the spacecraft when it was problem-free. Launched on September 5, 1977, the main purpose of the space probe was to explore our solar system. However, its journey extended beyond its original destination. Voyager 1's story began with a unique twist. Months before reaching Jupiter, it began sending back images of the gas giant. These early images, which showed Jupiter's amazing swirling clouds and persistent Great Red Spot, were an instant hit at NASA's Jet Propulsion Laboratory. But this was only a prelude to a journey that would redefine space exploration. What set the stage for Voyager's amazing observations was the discovery of active volcanoes on Jupiter's moon Io. Slightly larger than Earth's moon, this modest moon had an impressive secret. It was the most volcanically active body in our entire solar system. Voyager 1's instruments detected unusual signals from Io, and the vivid images it captured revealed towering volcanic clouds and a surface ejected by volcanic material. Of these, Pele, one of Io's most prominent volcanoes, has erupted up to 30 times the height of Mount Everest, covering an area nearly the size of France. The secrets of our solar system have been revealed before our eyes. Before the recent astonishing discovery of 500 unidentified objects traversing space, the twin travelers surprised us after launch. One of their most anticipated discoveries was the existence of Jupiter's rings. These delicate rings, although fainter, added an aura of mystery to the already enigmatic gas giant. Voyager 1 added another piece to the puzzle, revealing that Europa, one of Jupiter's 53 named moons, was encased in an icy shell more than 60 miles thick. This challenged our previous assumptions about the nature of distant celestial bodies and ignited new curiosity about the possible habitability of icy moons. But there is more to the story. When the travelers said goodbye to Jupiter, they received an important handout: gravitational acceleration. This gravitational pull, like a cosmic slingshot, carried them to Saturn. Without it, they would have been stuck in the sun's gravitational pull and would not have been able to venture further into space. Voyager 1's path brought it close to Saturn's fascinating moon Titan.